Alright, so now we're going to look at electron configurations for ions. So remember, an ion is just something that has a charge. So for example, O2 minus is an ion. So if we were to write the electron configuration for just plain old oxygen, remember it would be 1s2, 2s2, 2p4. That's regular oxygen. However, O2 minus has 2 additional electrons because of its -2 charge. So you're going to add 2 electrons to that. So 2p4 instead will become 2p6. So 2p4, now 2p6. And this is the electron configuration for oxygen. And that is the same as neon. So most ions want to have an electron configuration similar to a noble gas. We say it's isoelectronic with it. So here's another one, Ca2+. So if I just write CAs, and again I'm assuming you know this from before, so if you're not sure how to do this, go back and look at an earlier video. But here is calcium's electron configuration. So +2 means it lost 2 electrons. So we're going to remove 2 electrons from the outer thing. The outermost shell is this 4 shell, so we take those 2 electrons out, we just kind of get rid of this. So this is the electron configuration for calcium, which again is similar to or exactly the same as argon. Now there are some strange exceptions that come up for the positive ions. So for example, if I write iron 2+, and first I write the electron configuration for just plain iron, 1s2, 2s2, 2p6, 3s2. So this is the electron configuration for iron normally. We're removing 2 of the outer electrons. So the temptation is going to be to pull them off the end here because that's the last one you wrote. But the outer shell is actually the 4s. 4 is a larger number, so that's the outer shell of iron. So when we pull the 2 electrons off, we're actually going to pull them out of here first. So this is where the electrons come from. So the full configuration of Fe2+ is this without the s in there. And that only really comes up for positive ions, so just be aware of them. Here's another one. So here is the electron configuration for lead, the abbreviated one. So we're removing 4 electrons from Pb. So again, where do they come from? They always come off the outermost shell. So the outermost shell is the 6 shell, right, 6, but this one only has 2. So we're going to take these 2 off. We still have 2 more to come off. So there's also another part of the 6 shell here. So these are where they're going to come off as well. So Pb4+ will be xenon 4f14, 5d10. So just be aware for some of these positive ions, they are a little bit trickier than the negative ones. The negative ones are pretty straightforward, you're just going to add them in. And that's how you do an electron configuration for an ion. So, till next time, I am Derek Genova. Have a delightful day.